We will be now in this today's session will be taking up few questions from the past CBSE Class 10 papers. Okay, first let me write down first question. If alpha and beta are the zeros of the polynomial x square plus px plus q, we have to find the value of alpha by beta plus 2 and multiplied by beta by alpha plus 2, where we know that alpha and beta are represented as the zeros of the given polynomial. Now in the given polynomial, alpha plus here a is 1. Let me write down, that becomes easier for you when you replace or substitute the values to find the sum and the product of the zeros. C is q. Sum of the zeros is given by alpha plus beta, that's in our polynomial becomes minus b by a, that's p by 1, that's p, and the product of the zeros is represented as alpha beta, that is given by c by a. So in the equation it becomes q by 1, that is q. Now we have to find this sum which says alpha by beta plus 2, beta by alpha plus 2. So if you take an LCM here, why do you take LCM? Either or you remove the bracket. So let us remove the bracket, because later on in that case also I'll have to remove the brackets. So alpha by beta and beta by alpha, that is alpha beta by beta alpha plus it is 2 alpha by beta, it's again 2 beta by alpha plus 4. Now this is 1. So I'm getting this is 1, and here if I can take 2 common, I'll be left with a alpha by beta plus beta by alpha plus 4. One plus, if I keep this and I take up an LCM, it will be alpha square plus beta square plus 4. So this plus 1 plus 4, why do I keep it like that? Let us make it 5, and this needs to be now replaced because I only have alpha plus beta and alpha beta, but I don't have alpha square plus beta square. So let us try and represent alpha square plus beta square as alpha plus beta whole square. If you remember the formula of a plus b whole square, it is a square plus b square minus 2ab, right? So if I keep this as alpha plus beta whole square minus 2 alpha beta, that will be left me, just that will leave me with alpha square plus beta square, right? Let this be by as it is. Now I continue it here and use another color to make it separate. 5 plus, now alpha plus beta whole square, that gives you minus p square minus 2 alpha beta, that's given by q here, by alpha beta is again a q. So it is 5 plus p square minus 2q by q. Let me take LCM and continue. So it becomes 5q plus pq minus 2q by whole q. Oh, that was p square. Oh, I had this 2 here, I think, which I left. So that would make this 2p square, and here it is made as it is minus 2 alpha beta, so 2q, that makes it 4q. So it is 4q, 5q, 4q, that makes it q plus pq. So it is p plus 2pq by 2p square by q. This becomes the answer to the value of alpha by beta plus 2 and beta by alpha plus 2. I hope you got this, and now we move on to another type of question. It says if x plus a, oh sorry, this should be small a, is a factor of the polynomial. What is the fact given for? Oh, I'm so sorry for the spell mistake. You can add on a o to it, but the polynomial given is x square plus lx plus m. X plus a is factor of this polynomial as well as this polynomial. We have to prove that. It says then prove that. What do we prove? It says a is equal to m minus k by l minus n. Now when it says a plus a is a factor of this polynomial, that means x plus a is equal to the factor. So I don't write this, but here I simply write this being the px. So p minus a should be 0 here in the first, even in the second one. So I'm taking the first one. In the first one it becomes, because x plus a is the factor, so p a minus a will be minus a whole square plus a into minus a plus m. That should be equal to 0. So it is a square plus, oh sorry, it is minus a, so that becomes minus al plus m equals 0. This is one equation. On the other hand, if I look into the second one, even the same thing applies. P minus a will also be 0 for the second one, because the second one also has a factor x plus a. So again I replace minus a whole square plus n minus a plus k, that should be equal to 0. So a square minus an plus k, that equals 0. So we have now two equations which says a square minus al plus m equals 0 and a square minus an plus k equals 0. As because both the equations are equal to 0, we can equate them, the left sides. So that would give us the following, the one which I'm writing. It is a square minus al plus m is equal to a square minus an plus k. Now if this a square get cancelled, I'm left with minus al plus an equals sorry, k minus m. I need to multiply the whole equation with a minus. Is that going to help me? Yeah, that's going to help me perhaps. Yeah, I need to equate the multiply the whole of this with a minus, so that makes it al minus an equals minus k plus m. Let me rearrange the right side. That will help us to our need. Now a can be taken common. I'm left with l minus n, and this will remain as m minus k. So L can be m minus k by L minus n. This is what we had to prove here. So we got our proof right. The next page, I give you a question for solution by yourself. Now I have been doing them by myself. I give you a question. It says if alpha and beta are the zeros of the polynomial, the given polynomial will be 2x square minus x plus k satisfy the relation 3 alpha plus 3 beta plus alpha beta equals 0. Then find value. I won't be able to make within that space, so maybe find the value of k and the zeros of the polynomial. Just to help you out in finding out the right answer, not finding out the right answer, to know if you have found out the right answer, I give you the answers to first part and the second part so that you can match with it. K you must find as minus 3, and the zeros of the polynomial will now be x will be minus 1 and x will also be 3 by 2. I hope you got this correct. Thank you.